gives you a little perspective, doesn't it? So this is only a partial diagram. The richness of the whole thing is kind of overwhelming, but this gives you an idea. We know these relationships. So this is where we stand. You know, we're one species of millions, no more favored by any objective process than any of the other creatures in this diagram. Every one of the species that are alive today is a winner. Some are dying out now, they're becoming losers, unfortunately. But every species has a long, successful evolutionary history, and no species has a longer evolutionary history than another. We all trace ourselves back to that common ancestor 3.8 billion years ago. So this is another important lesson from biology that, you know, when you read Genesis where it says God gave us dominion over all, no, we don't. We are partners on this planet. And it'd be better if we appreciated that than that we use this religious dogma to justify bad decision-making in our understanding of the environment. And we have a lot more information too, and I'm just going to throw a complicated diagram at you. Don't cry. But I really like this diagram. It's from a recent paper where what they did is they used phylogenomic methods to categorize different genes and determine when they appeared in evolutionary history. So for instance, you know, some genes, you can look at a bacterium, you can look at a plant, you can look at us, and we all have those genes. They're all present in us. Those are shared genes. So you know, those go all the way back to the last common ancestor of all those creatures. You can say that gene arose 2.1 billion years ago when eukaryotes arose 3 or 4 billion years ago at the beginning of life. So we can date them that way. And whereas other genes, like for instance receptor tyrosine kinases, are present only in animals. They're not found in plants or fungi, they're not found in bacteria. And so when we find those genes, we say, okay, well, that gene arose roughly 600 million years ago when animals first evolved. Okay, so we can get this kind of picture there. Now, when we look at just the red part of that graph, what that's showing is when did all the genes appear? And what you can see is that the majority of the genes we're familiar with that are present in our body actually arose between 3 and 3.5 billion years ago. So we have deep history on our genome. All this stuff arose then. And then there's been this continuous dribble of new genes. That's why the red, so old stuff is at the top, new stuff is at the bottom. So there's just been a slow, continuous dribble of new genes into our organisms over time, but at a fairly low rate. We're mainly working off of this gigantic archive of genetic diversity that was generated at the beginning of life's origin, which is kind of cool if you think about it, right? This is amazing stuff. We're looking at the raw material of the information revolution in biology, and we can tell you when it arose. It's like looking at the history of microcomputers in this country. We've got all kinds of detail there, but we've got the same kinds of detail understanding for genetic processes as well. You know, and there's other details we can extract from this. You know, like we know from looking at this, and this makes so much sense, that the earliest genes were involved, for instance, in glycolysis, part of metabolism, where you break apart sugar to get energy. But genes that were involved in aerobic metabolism that require oxygen arose only later, because the early Earth did not have free oxygen in the atmosphere. It was only later when it was present that we began to evolve genes to take advantage of that. So we can see everything and correlate it to the history, the geological history of the planet, as well as the biological history. And you know, this is cool and beautiful stuff. This is why I'm a biologist, because biology produces so much awesome complexity, and biologists love to embrace it. We're not looking for a grossly simplified picture of the world. We're looking for reality, and reality is really messy and cool and complicated. Okay, another example of this. Oh man, I just got done teaching this stuff in the class, so yeah, I don't want to overwhelm you. But what this is what science is really good at. That is teasing apart relationships. What this is a tiny piece of the body of data we have, in this case, looking at the components of the photoreceptors in your eyes. Actually, we're looking at photoreceptors in our eyes on the right and photoreceptors in the eyes of arthropods on the left, but this is a little comparative study. So what these are delicate little cells that collect photons and turn them into changes in membrane properties that are then conducted deeper through the retina to your brain. And we know so much about these molecules. The light collectors like opsin, the signaling molecules like phospholipase C, and the effector molecules like GMP and diacylglycerides that trigger changes in ion fluxes across the membranes. That, I could just take over the university for a week if you'd like, and we just talk about nothing but this. There is so much stuff here. You probably want to escape tonight, don't you? Okay, one day we'll have a seminar after this week. Anyway, there's all this richness that we have, and this is an evolutionary story. We built this by looking at evolutionary relationships. So, all this stuff is out there. It's all part of biology. It's all rejected by creationists. And it is all ignored by religion. None of this is in any of the holy books. Now, when I say that, I know exactly what religious people would then say to me. They will turn around and say to me, well, that's right. The Bible is not a science textbook. You're reading it wrong if you try to find molecular biology in it. And to that I would say, exactly. It is not a science textbook. So why are you telling me I must constrain science teaching to that which does not defy religious teachings? Why must science respect a body of beliefs that are at best orthogonal to our subject and to an all too common worst are contradicting science? These are things that you can get religious people to actually agree with you on. Because once you hit them with just a little bit of science, you realize that's not in the Bible. Some people respond by telling you, well, then it's wrong because it's not in the Bible. But rational Christians, well, you can convince them. Okay, we're not going to teach the Bible in the science classroom. Now, your eye is not just complicated, but it's really old. This is something that people don't quite realize. You've got your boyfriend, your girlfriend, your wife, your husband, whatever. Have you ever looked deeply into their eyes, right? Eyes are beautiful. We like to look at people's eyes and focus on them. Those eyes are about 400 million years old. That the design for your eye was worked out by evolution 400 million years ago. And it was done. Actually, our eyes are in some ways are slightly degraded from the pinnacle. Bird eyes are much better than ours. Reptile eyes are even better. And I hate to tell you this, but the best eyes on the planet are in fish. So we're kind of corrupted descendants of these beautiful eyes. But this is an illustration of the relationship between these eyes to show that, they arose 400 or so million years ago. The molecular toolkit behind them, things like that phototransduction pathway I showed you last page, that was 600 million years old. So all this stuff is really, really ancient. I think that's wonderful too, that here's this depth to our history that you have to appreciate. And so what this is doing is making the point that the eyes of fish and men are pretty much equivalent in form, in tissue arrangements, in constituent genes, in function, and physiology. And we can lump them together as end products of the same evolutionary process. Good enough and stable enough to persist for 500 million years almost. So this is part of the science story, the inspiring part, that we're cousins to hagfish and we're children of worms. And I find that idea so much more inspiring than the false notion that we are special little children of a deity. A deity who tells his chosen species a selective truth about their existence that doesn't even mention cephalopods or cephalochordates, and that can be falsified by anyone who actually looks at the world around them with open eyes. That's a shame, too, because there is so much beauty in the natural world. Beauty, like the eyes of a lamprey. Seriously, if you ever catch a lamprey, I know people think of them as pests, but take a good, deep look in their eyes. They're just as beautiful as your lovers. But don't kiss them. Don't go that far. But you know, you can appreciate this kind of beauty that's there. And you know, that leads me to this last, penultimate slide here. X-Space had this beautiful cartoon I had to show you. This is something you hear all the time. People say, you scientists, you take the wonder and beauty of everything by trying to analyze it. Yet, talk to scientists, what you find is scientists who are entranced by the beauty of their subject. And it doesn't matter whether it's a hagfish, or a slime mold, or a squid, or anything. They're gorgeous when you look at them. And somehow we've got this idea that science deprives us of beauty and poetry in the world when it does exactly the opposite. It's the source of the greatest poetry of them all because it is true. So nature is what we must teach and study, not dead myths, not false fables. Science is about exploring the splendor of reality, while religion is about making up lies about how the universe works. So of course they're incompatible. One is bullshit and the other is not. It makes it really simple to make this choice. Okay, I'm going to show you one last slide before I let you escape here. And it's my favorite Darwin quote. Now, there are a lot of great Darwin quotes to choose from, and many of you are probably familiar with the one about endless forms most beautiful. His final paragraph it's just stunning in how well written it is, how gorgeous. But on contrary, this is my favorite. It's from earlier in the book, and it's so relevant to this subject. He says it's so easy to hide our ignorance under such expressions as the plan of creation or unity of design, etc. And to think that we give an explanation when we only restate a fact. Anyone whose disposition leads him to attach more weight to unexplained difficulties than to the explanation of a certain number of facts will certainly reject the theory. This is a defense he's making of the theory of evolution. A few naturalists endowed with much flexibility in mind and have already begun to doubt the immutability of species may be influenced by this volume, but I look with confidence to the future, to young and rising naturalists who will be able to view both sides of the question with impartiality. Whoever is led to believe that species are immutable, will do good service by conscientiously expressing his conviction. For thus only can the load of prejudice by which the subject is overwhelmed can be removed. Now, this is such a good statement for anything any of you students are learning in college, is what you've got to do is be an advocate for good ideas. That you do good service by conscientiously expressing your convictions, by telling other people about what you know, by sharing your knowledge. And that's the obligation all of us scientists have, is to conscientiously express those convictions. And with that, I'll finally shut up and let you guys pester me with questions. You'll be fine. Unless you have no questions, I answered them all, right?